The progress of humankind is driven by our desire to explore new territory, examine new horizons, and dream new dreams. In the early days of scientific discovery, we looked outward, seeking to uncover the mysteries of the universe we could see and the mysteries that lay just beyond our grasp. As science progressed, so did our reach and our focus. Today, we put a new generation of scientific tools and scientific minds to work on finding new ways to explore and explain our world and solve its problems. The National Center for Supercomputing Applications at the University of Illinois, Urbana-Champaign, proudly introduces the winners of the 1994 Industrial Grand Challenge Award. Dr. Mike Skriner, Dr. Ernie Plummer, and their research and development teams at FMC Corporation. The unique Industrial Partner Program at NCSA recognizes the individual creativity and drive which motivate American industry. The Grand Challenge Award symbolizes the significant advances in computing combined with the representation of the winners' application work. This year, FMC joins an elite group of companies who discovered new and innovative applications for high-performance computing tools. 1992's Grand Challenge Award was presented to Dr. Robert Herman and Dr. David Heron of Eli Lilly and Company. They were recognized for their use of advanced computing technology for improving the drug design process. Their work focused on a cure for asthma.
We design these molecules using the results of all of our computer work, and then we just walk a few feet into the laboratory and make them, and these are our potential new therapies for tomorrow. And having that power to be able to see it and design the molecules and then actually make them is really exciting.
In 1993, John Bettner and Dave Stevenson, design engineers for Caterpillar Tractor, were recognized for their use of virtual reality to design earth-moving equipment.
There's a tremendous advantage here for Caterpillar. We're able to dramatically shorten the amount of time it takes us to analyze a new concept and to actually try it out. The financial savings is going to be huge because we'll be able to reduce the amount of pre-production builds that we have to pay for. If we can design everything on the computer here and test everything out, we can take the first vehicle we put together and sell it right to the customer and be confident that he's going to be satisfied.
For FMC, earning the Industrial Grand Challenge Award began with the creation of prototypes to model new products and processes. FMC also applied the virtual reality technology pioneered by Caterpillar.
There was a radically new era in computing emerging globally. And so our mission through working with NCSA was to access that technology to understand how it would pertain in our processes in modeling and simulation in FMC. At the time we joined as a partner at NCSA, we observed what the other corporations were doing there, and of course that was a strong stimulus in having us join in the first place. Shortly afterwards, Caterpillar also joined, and we started sharing technology on a pre-competitive basis, and we could see what they were doing, and they of course could see the sort of software development and what it is we were doing. And as a result of that, this collaboration grew up where we could share technology and tools and leverage our resources so that we didn't have to duplicate all the development that was required. That makes FMC more competitive, and it returns products that perform better, that are safer, that have longer lives to our customers, all at a lower cost. It makes FMC more competitive in the global marketplace.
FMC's task was to pioneer the access, exploration, and transfer of technology to provide significant business benefits to the company's worldwide operations. This led to new directions for Ernie Plummer's agricultural research, which has ramifications far beyond FMC's product line. Every year, nearly 60 million people around the world die from hunger. Meanwhile, the land available for production agriculture decreases as scientists continue to seek new solutions for increasing crop yields while sustaining or improving a delicate environmental balance. On the foundation of Dr. Schreiner's work, Dr. Ernie Plummer and his team attacked the problem at its very essence. Their challenge was clear.
To take advantages of the changes in computer technology, mainly high-performance computer technology, and apply that technology to the discovery of new herbicides and insecticides. The market itself, of course, is very profoundly influenced by the environmental concerns of the public. We need compounds that are safer. We need compounds that are more efficacious, that we need to apply less of them and achieve our goals in a better fashion. To do that, we have to refine our approach to their discovery. We want to try to control an insect in a way using a biochemical process that is only present in insects. The development of an insect is totally under the control of hormones. If we can control that hormone balance, we can control the insect. We can control them as they develop and kill them, or at least eliminate them from feeding before they get large enough to do any serious damage to the plants.
But reducing the environmental impact was also a significant part of the equation.
The amount put on the land is also the amount that's going to go into the environment, the amount that has to either be degraded or it will leach into watershed. We want to make that as small amount as possible.
The solution for Dr. Plummer and his team was to isolate the building blocks that dictate insect growth, enzymes and receptors. The team built three-dimensional models of those building blocks, or target sites, using high-performance computers, or HPCs. Applying a technique that could best be described as a virtual reality Petri dish, models of new compounds were tested against the target sites to determine their effectiveness.
We can actually visualize what it looks like as it sits in the target site and what changes we can make to it in order to increase its activity. The electronic images are dynamic models. They move like the real world moves, and gives us a much more accurate view of what we're seeing. There's no doubt that visualization is a very important part of what we're doing, because the chemist ultimately has to see the interaction with the target site, and by seeing, allow his imagination or her imagination to discover a new compound.
Plummer's team has developed new tools to significantly increase the probability of finding new chemicals which are both highly effective in the field and environmentally friendly. In the process, they brought FMC and the world closer to improved agricultural yield. Again, the research conducted by Dr. Mike Schreiner and his team made these and other FMC breakthroughs possible.
Shortly after joining at NCSA, we found that we were able to start work on literally dozens of projects that we could not have performed before. And examples include impact and penetration of advanced armor systems, dynamic simulation of vehicles and machinery, such as rotary sterilizers and the transfer of food cans into the rotary at the rate of 10 cans a second, which is a very complex process. Simulation of our manufacturing processes, such as metal forging and casting and welding. Simulation of the flow of granular materials, such as flow, compaction, where there's quality issues that had been unresolved for many years. Sparging, in chemical plant, fluid mechanics, computational fluid dynamics, simulations of flow in valves to optimize the performance of our valves, and so forth. Back in 1988, when we joined NCSA, the cost of our modeling and simulation was $540 per hour. Now, our high-performance computing workstations cost us $7 per hour to run. If we factor in also the increase in speed that's been achieved, we have reduced the cost of a unit of computing by 1,900 times. That represents 450% reduction every year, not 10% or 20%, but 450% every year. What that means for FMC is that we can get for every computing dollar 1,900 times more, making FMC more competitive in the global marketplace and directly benefiting our customers in better performing, lower cost products.
One of the more significant events which occurred in parallel with the partnership between FMC and the NCSA is the development in FMC's Corporate Technology Center of proprietary software called HANDS. HANDS is a dynamic simulation code which makes possible the concept of interactive design optimization. Using the HANDS software, a machine virtual prototype can be changed to explore design concepts, run the simulation in a matter of seconds, and allow the designer to see and comprehend the results all in real time. Another innovative development, also heavily dependent on modeling and simulation, is the technology for predicting the life of machinery, vehicles, and process plants. FMC identifies this principle as fitness for purpose.
Under this concept, we can design products just right for the application. Overly designed products are unnecessarily costly for our customers. On the other hand, products that are under-designed may not perform their specified function. So you can see neither of these concepts are really acceptable. Under fitness for purpose, we can design it just right. You know, I've worked in industry for my entire career of over 27 years. And in my opinion, we're living in the most exciting of times because of the evolution of technology, what we see happening around us in high-performance computing and at NCSA, and in the technology within FMC, particularly my team here at the Corporate Technology Center. We're designing our products, machinery, vehicles, chemical plant, and chemical processes in the computers that will be done faster and will make them more efficient and cost-effective and safer and easier to use through virtual reality and virtual prototyping. That will create enormous benefits for FMC and our customers and consumers worldwide well into the 21st century.
The long-term value of the partnership between FMC and NCSA is clear. Scientific innovations will result in competitive advantages for U.S. businesses on a global scale. For FMC, the partnership is a critical step toward achieving its new corporate vision.
If you really look at what our mission is and what the mission of this stuff ought to be, it ought to be to bring decision-making power as far forward to the product cycle development area as possible. If we start out in concept design with decision-making capabilities and some of this enabling technologies, it'll allow us to make decisions that prevent us from making scrap down in the manufacturing areas. It'll prevent problems in the field. It just has so much potential.
I think that what you're going to find is all corporations by the turn of the century are going to take it for granted that every product they have has a virtual version in software. And of course, they're going to want to look at it and interact with it. Now, they may not call that virtual reality by the year 2000. They just may say it's the virtual prototype. But every company is going to be doing that. And the only advantage a company can have is being there early enough that they can learn and go up the learning curve and begin to embed this in the product process and the design process and the manufacturing process and the maintenance process and the marketing process and the training process. That takes years. Well, you can either wait until everybody else has done it and then get on the curve and spend several years trying to catch up, or you can be what I see FMC being, and that's a leader.
A meeting of the minds, a sharing of ideas, tools, and technology, a process that helps fuel the progress of a nation. With the continued support and encouragement of the National Center for Supercomputing Applications and the University of Illinois, partnerships like these are possible. And it is through partnerships and the efforts of research pioneers like Ernie Plummer and Mike Schreiner that the U.S. is not only better able to compete, but also to command the leadership position in the global market.